Hey, this is Brian with Quanta Engineering, and I field a lot of science questions. Some of them happen to be space related. And this particular question is, why do I only see one side of the moon? Is the moon not rotating? And how does that all work? And so I just wanted to share with you just a little graphical depiction. And if you imagine yourself being on a roundabout, okay, because that's something that we can all relate to. Roundabout, the dimensions are close and things like that. If a car, and here I just drawn a rectangle or a square, this same width and length, okay, and then what I've done is I've placed myself, a person, 6 inches off the side of the roundabout. That's a vantage point, and then I've got a curve of rotation. I can just drop in a circle here and just show you that. So that's my path of travel, okay, and this object will just simply travel around that object, okay. Now you'll notice immediately that this face, the face that's closest to me, is always facing the roundabout. Okay, think of your car. The driver's side car is always facing the roundabout. Now what you'll also notice is that on the back side of the car, I have a rear end, the rear end of the car, and I can see the rear end as it starts to travel, but look at the angle between the front and the rear. Okay, as I travel further and further and further, I never really get to a point. There gets to be a point, actually about right close to here, where all of a sudden I can see the side of the side of the car facing me and the rear of the car, and I can actually get some visibility. Now the problem is that is a square surface. Also, the other part is look at the difference in ratios between my roundabout, 240 inches, my person, 6 inches, and just scale these up. Think of them as feet, 240 feet, or 35 feet, 35 feet, etc. It's still a very small distance between my orbit and my dimensions and my roundabout. That the ratio of dimensions is really low. Okay, if I were to really look at it, I would need to go look at a representation of the moon and the Earth. So the Earth is 12,742 kilometers in diameter. It's about 7,920 miles. Okay, the moon is about 3,500 kilometers across. Okay, or let's see here, what was that dimension? The moon's diameter is 2,159 miles in diameter ish. Okay. So, and then the distance, it's around 1,000 kilometers. So, 238,000 miles away. So what happens is, because you now have the distance between my center of my Earth and the center of my rotation of the moon and the center or the person's vantage point, okay, I'm now dealing with a much greater representation of my or much smaller angles that I'm dealing with. So as I rotate around, the problem I'm going to run into is that it never develops much of an angle as I rotate. And even if I come out here and zoom out, because remember it was mostly all the way down at the side. Let me just bring it all the way down. I really need to invest in a space pilot so I can pan and click and move all at the same time. So you'll notice that my vantage point never gains much. Okay, it never gains much. This is a really low angle. In fact, it's such a small angle, 0.01 degrees. Okay, it's such a small angle that different points in this rotation, the CAD software is not accurate enough to treat it as an angle. It's so close to parallel that the CAD software will actually treat it as a distance. Okay, so now, just to show you, that's what happens. That's why it's rotating. If I were to go back to my shorter version, my version that's not scaled properly, if this was not tidally locked, okay, if the moon did in fact, or the car did in fact just stay in the same orientation, as I rotated around, that's what it would look like. I would see the back side of the moon. I would see all sides of the moon. Okay, the moon would not be going through any revolutions. That would be a non-revolving body. Okay, it would be an orbiting body. Okay, but non-revolving. Okay, now for the moon itself, if I were to take it and let's just change, let's see here. Let's go to this one, and let's bring this back to, say, 240 and 6 inches. And this is 200. Okay, and this is 35. Okay, so this would be like my moon. So now, in this case, again, we have a vantage point. I hate it when SOLIDWORKS does that. So, as I drag it around, okay, I have a vantage point. Here, that's my tangency. That's what I can actually see. And then this is my hemisphere, what is visible from normal to the Earth. Okay, now I can see the tangency goes slightly past my hemisphere, no big deal. Okay, but as I rotate this, you'll see that my angle is still not very large. The maximum angle it gets to is right about when it's at the horizon. And just to put that in perspective, that's less than 1 degree of visibility. Okay, 1 degree is pretty small. Okay, now again, that is when it's tidally locked. If it was not tidally locked, I get rid of my perpendicularity. Okay, and I set this to a horizontal. Okay, when my moon is facing me, I can see that hemisphere. I can see this half of it. And what we can do here is I can just trim this and keep it, boom. And what I'll do is change this to construction again. That way when I select one half. Select that half, okay? As I rotate, all of a sudden I'm seeing the top half when the moon is horizontal to me. And that's not what we see. And that's one of the proofs of why we know the moon is rotating. So it is orbiting, but it is also rotating. And then as we go around, this is the reason why people on the other side of the planet do not see the back side of the moon, okay, because the moon is rotating. So I hope that makes sense to everyone. As you move into the full size, full scale, it is locked, and what will happen is as you move, the angle gets so shallow that you really can't see much of anything. In fact, if I were to bring this, let's just make this horizontal, okay? My visibility of the, because the Earth's diameter, and the reason this works is because the Earth's diameter is larger than the moon, so there is a shallow angle there. But what I want to point out is the angle between my visibility and the hemisphere is so low that the software can barely tell. But if I were to measure that, okay, it's showing me 0.021 thousand kilometers. Okay, now if I were to come out here and I were to say, okay, let's say from the surface of the moon up to that line, okay, let's just make it the same distance. Okay, so the distance passed. Actually, you know what? Let's make it 1 kilometer. Let's just make it 1 kilometer. 0, 1. Okay, so the question is what distance is that? Boom to boom. So I'm looking at a distance of 59 kilometers. So this would be like laying your head down on pavement and marking a distance 59 inches away, and then trying to reconcile what you see across that very, very shallow perception. We lose all sense of perception at those scales. And so that's why you really can't see much. In fact, the last couple of degrees of the moon's surface, you pretty much lose all sense of depth and perception. And that's a natural phenomenon. That's just normal. That's because the difference in height to distance is so small, it's not even funny. So yeah, that is just explaining the mechanics of the Earth and the moon and how the moon is rotating and how we know it is rotating. So I hope this helps. If you have any questions, feel free to ask and let me know. Comment below and let me know what you think. If you have any questions, and I can explain them further. Have a good day. Thanks.